Today, we will build a Simio simulation for a hot dog stand. The hot dog stand is open from 9 a.m. to 3 p.m. However, we will have a busier period during the lunch hour when everybody is hungry. We're going to model the time-varying arrival rates in Simio using rate tables. We're also curious to see how much better the system might be if we have multiple staff during the busy periods. The time-varying staffing level will be modeled in Simio using what are called work schedules. In addition, we're going to model other queuing behavior with this example, namely balking and reneging. With balking, we have the case where customers come to the place of business, in this case, the hot dog stand. They see the line and they decide not to even join the line and leave. For reneging, this is the queuing behavior when people enter the queue and wait in the line for some time and then leave the queue before being served. In our example, we will have 1.5 minutes on average for the time to fill a customer order, and we'll model this using an exponential distribution. We have the arrive times for 200 customers in hours in the arrive times file. In column A, we have the arrive times. For example, the times that are between 0 and 1, those represent times where customers arrive within the first hour. Let's count the number of times we have customers arriving within each hour. At hour 1, 2, 3, 4, 5, and 6, we have 6 hours for this particular simulation model because the hot dog stand is open from 9 a.m. to 3 p.m., which is a 6-hour period. For the number of arrivals in the first hour, we can determine this using the COUNTIF formula. We just need to do a COUNTIF of the values in column A and check to see if it is less than the value in C2, which is 1. To determine the number of arrivals between hours 1 and 2, we would then need a COUNTIFs formula. Here we'll have the number of arrivals less than C3, so when we have less than 2, and then also those that are greater than or equal to 1, which is the value in C2. That will give us the number of arrivals that arrive within the second hour from hour 1 to 2. We can do the same thing for the hours 2, 3, 4, 5, and 6 by copying down the formula. Then we can use a sum formula to check to make sure that the total number of arrivals that we have for the 6 hours does represent the 200 different customers that we have in this data set. When we apply the formulas, we should get these numbers. The number of arrivals in hour 1 will be 22. The number of arrivals in hour 2 will be 12. The number of arrivals in hour 3 will be 57. The number of arrivals in hour 4 will be 57. Finally, in the hour 5, we will have 26 arrivals, and you should have 26 arrivals as well for hour 6. A bar chart of those number of arrivals is shown here. We have clearly a busier period during the 3rd and 4th hour. This represents the lunch period from 11 a.m. to 12:59 p.m. Let's create the hot dog stand simulation in Simio. We need one source, one server, one sink, and we'll have one model entity. Let's call the model entity customers. Let's join the source 1 to server 1 with a connector. And let's join server 1 to sync 1 with the connector. Let's rename our server 1 to vendor. Let's set up the rate tables in Simio for our time varying arrivals. Select Data, then Rate Tables. Then under Rate Tables, Create Table will see the plus symbol. Click this button to create a new rate table. The default name is Rate Table 1. You can leave that, or you can change the name if you prefer. The number of intervals that we will have is 6, because there are 6 hours for this hot dog stand simulation. We can change that number to 6. Now we have 6 different hours, and we want to enter the data that we determined for the number of arrivals in each hour. We had 22 for the first hour, 12 for the second hour, 57 for the third, 57 for the fourth, 26 for the fifth, and then 26 for the sixth. Now we can go back to the facility view. Select the source, and now, instead of having inter-arrival time, we can specify that we want a time-varying arrival rate. Then we're asked to include the rate table. Let's select Rate Table 1 to have the arrivals come through with Rate Table 1 that we just created. Next, let's create the processing time for the vendor. Here, we'll use an exponential distribution with an average service time of 1.5 minutes. And the units are set to minutes. Let's create an animated status plot to show the number in system and the average number in system as the simulation runs. To do this, click Animation Time Plot. We'll create the plot. We'll set an expression. Customers.population.number in system. Let's give this a label of NIS for number in system. We can add an additional expression. Click Add. This one will be customers.population.numberinsystem.average. We'll set a label of average NIS for average number in system. Let's change the title on the plot. Click Appearance. Now the title, instead of plot, we'll call this number in system. We'll change the number of hours to 6 hours. Now let's run this simulation. We'll set the starting time to 9 a.m. And we'll set the run length to 6 hours. Let's increase the speed factor. And run the simulation. As we see, the status plot is updated in real time as we're running the simulation model. Notice that the scale increases dramatically during the busy lunchtime period. We see the number in the system growing up to 35, and then as we reach the last 2 hours, we see a dramatic drop in the number in system. Let's modify the simulation model to have an extra staff member during the busy period. We'll use the Work Schedules feature in Simio to do this. Click Data, Work Schedules. We're going to use the standard week, but we're going to change this to standard 9 to 3. This hot dog stand is only open from 9 to 3. Now we will update the standard day. We will divide this into 3 staffing periods. I'll have the first one from 9 a.m. It'll be for 2 hours. We'll have another one from 11 a.m. for another 2-hour period. We can add a third one from 1 p.m. to 3 p.m. The value column represents the number of workers that we have. To To have 2 workers during the busy period from 11 a.m. to 1 p.m., set this value to 2. Now go back to the facility view. Select the vendor. Then the capacity type. Instead of fixed, we set this to work schedule. And then we select the standard week work schedule that we just created. Now we try running the simulation model. We should see better performance in this system. Let's try. Now we see the status plot. It's updating in real time. As before, we see the number in system. At first, it hasn't gone up beyond 4. Then when the busy period begins, we have 2 workers. We are seeing an increase, but it's not anywhere near the number in system that we had before when we only had 1 worker. See that the peak goes to 14 in this case, which is much less than what we had before. Next, we'll add queuing behavior to the model. We'll add balking and reneging. To do this, we will need 3 separate sinks. The first sink will represent the customers that are served, the second sink will be for customers that balk, and the third sink will be for customers that renege. For our first example, let's set up the logic for balking. Select the vendor. Then under the buffer logic, change the input buffer. Capacity from infinite to 3. In our example, we will set this up so that customers will balk if there are 3 customers in the queue. The next part is under balking and reneging options. We'll change the balk decision to block those cases. Then we will send those that are blocked, when there are 3 or more customers already in the queue, we will then put them to input at balk so that it will go to the balk sink. Next, let's look at how to set up the reneging behavior. Again, it's under buffer logic. Here, there's a renege triggers option with the rows plus the 3 dots. Click here and click Add. In our example, we will set up reneging so that 50% of the customers will renege after waiting for 4 minutes. To do this, we'll have a time-based renege trigger. The duration we'll set here to be 4 minutes. Make sure to change the units from hours to minutes. The renege decision is going to be probabilistic, and we'll set the renege condition to be a probability of 0.5 or 50%. The last step is to set the renege node name. We will want customers to renege to the input at renege. When we hit close, then this way, when we run our system, any customers that balk or renege will go to the corresponding sync nodes. I hope you enjoyed this video. Take care.